All right, so we're going to look at example 1 from our textbook from section 2.5. And what this wants us to do is find the limit as x approaches 3 of x squared minus 4x plus 3, all that over x squared plus x minus 12. So if we think about putting 3 up here, we get 3 squared is 9. 9 minus 12 is a negative 3, because we'd plug 3 in for x, and we get negative 4 times 3 is negative 12. So 9 minus 12 is negative 3, plus 3 says the top is 0. 3 squared is 9, plus another 3 is another 12. 12 minus 12 is 0. So we are in form 0 over 0, which is one of our indeterminate forms. So this is a indeterminate form. So we're going to try to factor this and then cancel out stuff and see what we end up with. So we're going to say, all right, x squared minus 4x plus 3, all that over x squared plus x minus 12. Top equals, stuff's going to factor, and the bottom stuff hopefully factors. If it doesn't factor, I guess we'll use quadratic formula. Let's see, two things multiply together to be 3, add up to negative 4. It's going to be a negative 1 and a negative 3. Two things add up to 1x, multiply together to a negative 12. So that's plus 4 and minus 3. So our minus 3's cancel. And we get that this expression here is equal to x minus 1 over x plus 4 for x not equal to 3. So as long as x isn't 3, this right here, this is the same as this original expression there. So as long as x doesn't equal as long as x doesn't equal 3, this and this, these are the same. That's horrible. Same as long as x is not equal to 3. Well, if you're looking at the limit at 3, then the limit doesn't actually care what 3 is. The limit cares about stuff to the left of 3, like 2.999, and stuff to the right of 3, like 3.0001. So the limit of this will equal the limit of this. These two limits will be equal because the limit doesn't depend on 3. So limit as x approaches 3 of x squared minus 4x plus 3, all that over x squared plus x minus 12 is the limit as x approaches 3 of x minus 1, all that over x plus 4. Now this is a rational function, and the bottom is not 0 when you put 3 in it. 3 plus 4 is 7. The top is, when you put 3 in for it, the top is 3 minus 1, which is 2. So this function here, this part here is continuous at 3. This is continuous at x equals 3. This is not continuous when x is negative 4. When x is negative 4, there's a vertical asymptote and stuff gets messed up. But we're not looking at negative 4, we're looking at 3. So this function is continuous at 3. So we can evaluate it by substitution. And that'll give us 2/7. And that is our answer. And that's going to do it.